This is your last video you have to watch for this class. All right, topic D, relative error. Basically, all relative error is how far off a person's experimental data is from their actual data. And so when you do relative error, you're going to do this a lot when you're in science class and you're doing labs, and hopefully when you go into college and you do, if you do any type of scientific research, you need to know what your relative error is, so that you can see if your experiment is even valid. Because if your relative error is too high, then your experiment it just becomes nullified. So how do I find relative error? Well, first of all, it's super easy. All you have to do is take your observed data, the data that you would have from the actual, like from the experiment itself, and then subtract the actual data, what you would expect to get, and then divide that by the actual data. But why do I have bars here? Those are absolute value bars, in case you can't tell, okay? All right, so literally it's just this formula. You have to memorize this formula, but once you memorize it, it's so easy to do the problem. All right, so question number 1. Davy measures the mass and volume of a piece of copper in the laboratory and uses his data to calculate the density of the metal. According to his results, the copper has a density of 8.37 grams per cubic centimeter. So this right here, this is your observed value. Okay. Curious about the accuracy of his results, Davy consults a reference table and finds that the accepted value is 8.92 grams per cubic centimeter. Sorry. What would Davy's relative error be to the nearest thousandth? So let's go ahead and figure that out. So remember, the formula is just observed minus actual. Take the absolute value of that and then divide it by the actual. Well, you know the observed number is 8.37. You don't have to worry about the units. And then you know that the actual value, or the accepted value, is 8.92. And then you divide it by the accepted. And then don't forget that you have to take the absolute value of these numbers right here. So when you subtract 8.92 from 8.37, you get negative 0.55, all right? So let's do that really quickly. 8.37 minus 8.92. You get negative 0.55, but you want to take the absolute value, so you end up getting positive 0.55. So you get 0.55 over 8.92. Divide those two numbers out. And you end up getting 0.061659. But it asks you to round to the nearest thousandth. So all you're going to have to do is round to the nearest thousandth. You get 0.062. Now, first thing I said is you don't have to worry about the units, because this is 0.55 grams per cubic centimeter right here. So you have your unit here and you also have your unit here. And because they're exactly the same, they will cancel each other out when you divide. So what does this 0.062 mean? It means that Davy's data is about 6.2% off of what you would expect. Okay, so his relative error is about 6.2. All right, I want you to read through number 2 and try number 2. Press pause until you've completed the problem and then come back to me to see how you've done. Okay, so remember, the formula is the absolute value of the observed data minus the actual data all over the actual data, okay? And in this problem, you know that the observed value is what he got, which was 2.85, okay? Minus the actual, which is 2.699. And that's all over the actual, which is 2.699, okay? So then you end up getting 0.151 over 2.699, which is 0.056 rounded to the nearest thousandth again. That means that he's off by 5.6%, okay? Now, number 3 is very tricky. Number 3 says Bob measured the side of a cube to be 5 inches, okay? The actual measurement of a side is 5.1 inches. What is the relative error in the calculation of the volume to the nearest hundredth? So normally what we would do is we would do 5 minus 5.1 divided by 5.1, right? But it's not asking you about the relative error in his measurement of the side. Rather, it's asking for the relative error in the calculation of the volume. So the first thing I have to do is find the volume of each side. Well, I know that the volume of a cube, I know the volume of any box is length times width times height, right? And I know that in a cube, all the sides are equal. So this is the observed volume because he observed it to be 5 inches. So I would do 5 times 5 times 5, right? But don't forget that when you have the volume of a cube, it's just the side cubed, okay? So my observed volume is, when you multiply 5 by 5 by 5, you end up getting 125, okay? So this is the observed volume. Now I have to calculate the actual volume. To find the actual volume, I'm going to do a very similar thing. I'm just going to take my actual side length, which is 5.1, and multiply it by itself 3 times. So I end up getting, let's see, 5.1 to the third power ends up being 132.651. So I'll go ahead and write that out. 132.651. All right, so now that I know the actual volume and the observed volume, because that's what it's asking me to do, I can plug it into my formula to find the relative error. So I would do 125 minus 132.651 all over 132.651, okay? Once you do all of that workout and you plug it into the calculator, I'm hoping that at this point in time you're okay with that. You'll get approximately 0.058. So he's about 5.8% off, or about 6% off for the calculation of his volume from what it really should be. All right. Hopefully you understand everything that we've done so far, and now we're just going to do a lot of practice.